Okay, we're ready to start the next unit dealing with a different type of number. So this is section 4.1 on the I can statement, as I can understand rational numbers in fraction and decimal form. And as a warm-up for this, let's just remind ourselves what integers are. Again, this isn't a technical definition, but it kind of covers all the basics and helps you remember to include everything. So the integers are the positive and negative whole numbers, including 0. A lot of people will forget 0 sometimes. Next warm-up question leading into what we're going to talk about today is, what is the root word of the word rational? So if you look at the word rational, there's a root word right there. The root word is ratio. Now when we talk about a ratio, you may have heard about a ratio before. There are a couple different ways that we can write a ratio. Say we were going to write the ratio of 3 and 4. We would write 3 to 4, the ratio of 3 to 4. We can write it with a colon, so we can do 3 colon 4. Those mean the same thing. And then probably the most useful way that we could write this is to write it as a fraction. We're comparing these numbers, 3 to 4, 3 to 4, and we're comparing 3 to 4. So writing as a fraction is a really good way to write a ratio, especially when we're dealing with math. So one of the reasons why we like integers is because they are nice whole numbers. And they're really familiar. We've been working with these for a while. Even the negative ones, they're not too bad to work with. So what I want to start with here is just an easy little example. Graph and label the following integers on the number line. And I've got these integers right here. And like I've mentioned before, it's always a good idea to start with 0. So we're going to put 0 on here. And it happens to be one of the numbers that we're going to graph, so I'm going to put a big dot right there. Negative 4, so we're going to count 4 in the negative direction, so we're going to go off to the left. So here's negative 4. 5 in the positive direction, so 5 is going to be right here, and then 2 in the positive direction, so that's going to end up right here. So we're going to put a 2 right there. And those are pretty easy to work with, but unfortunately most things in the real world don't happen in whole number increments. And you might be able to think of some examples, things in cooking or money or shopping or different things like that. So you may be doing a recipe that calls for a half a cup of flour. There's a fraction right there, a comparison of two numbers right there. Some other things might be money. You might go to the store and you might spend $5.33. So it's not $5 even, it's $5 and a little bit more. You may have go to a store and there may be a sale, and you may have a 20% off sale. And we'll talk more about how percents deal with fractions and decimals and that sort of thing, but it may only be 20%. Or you may be dealing with sales tax, and a typical sales tax might be anywhere from 5 to 8% or something like that. Here in Utah, I believe in most places it's about 6.825%. So there are a lot of times where we don't deal with whole numbers, whether they're positive or negative. So what we need to make sure is that we're comfortable with other types of numbers. And one of the main other type of numbers that we're going to need to be familiar with, they are called the rational numbers. So let's talk about what rational numbers are. Rational numbers, and this is kind of a technical definition, rational numbers are numbers that can be written as a ratio. There's the root word of the word rational. They can be written as a ratio of two integers. Okay? So if we can write it as a ratio like we did up above, write it something like this, a rational number is a number that can be written as a fraction. And we're going to deal with that a whole bunch today. We can write rational numbers as fractions. So some examples would be, say, 1/2. That's definitely a ratio of two integers. And you could also write it in its decimal form, which would be 0.5. Let's think about this number, negative 4. Is negative 4 a rational number? Is it a ratio of two integers? Well, remember, we can always make a number a fraction or make it a ratio by putting it over a 1. So I can put that over a 1, and there I go. We could also do something like this. This would be 1.33. Question there, is that a rational number? Well, let's see. This is 1 and 33 hundredths. So in fraction form, if we wrote it as a mixed number, this would be 1 and 33 hundredths. And then we could write it as one single ratio or one single fraction by doing 100 times 1, that's 100, plus 33, so that's 133 over 100. And there's that 1.33 written as a ratio. Okay, how about the number 0? Is 0 a rational number? Well, remember, we can always make a number into a fraction by putting it over a 1, so 0 is definitely a rational number. Okay, so there are a couple of examples. We'll see a bunch more today. I do want to take just a second to remind you about something like this. If we were to take this and write this as 1 over 0, or write another one that has 0 in the denominator, these are both integers. That part is true, but remember, you can't divide by 0, so this thing would not be allowed. That's not an integer, so keep that in mind. 0 on top is okay, 0 on the bottom is not. Okay, so here's the big idea. When somebody says rational number, what you can think is, oh, they're just talking about fractions. They're talking about dealing with a fraction. Okay, so we're going to graph and label a couple of rational numbers. The first couple are going to be in decimal form. So if we were to go through and look at this, so let's say 0's here, 1's here, 2's here, and so forth, this would be dealing with integers on the number line. So if we were doing something like this and graphing these guys right here, we have to be a little bit clever about how we're going to do this. You'll notice that all of these numbers are between 0 and 1. They're very small decimals. So what I did here is I took this part of the number line and I kind of expanded it. I kind of scaled that up. So this here would represent 0. This would represent 1. And then each one of these, if we count these are each tenths. So I'm going to write 0 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths right there, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and 10 tenths would look like this, okay, 1.0. So those are the decimal equivalents of each one of those. So let's go ahead and graph these. So 5 tenths would be right there, and that would be where that rational number is. It's right in between 0 and 1, smack dab in the middle. 0.1, 1 tenth, that's going to be closer to 0 than it is to 1 because it's just 1 tenth. 9 tenths, kind of the opposite there, really close to 1 instead of closer to 0. And then 0.25, we've got to think just a little bit about this one. 0.25, and sometimes it's helpful to think of decimals in terms of money. This would be like 50 cents and 10 cents and 90 cents. This is like 0 cents, and this is like $1 right here. So you can kind of see 10 cents would go here, 50 cents would go here, 90 cents would go right here. Well, what about 25 cents? Well, 25 cents is in between 20 cents and 30 cents, so it's in between 0.2 and 0.3. So it's right there, and because of that 5, it's right in between the two of those. So we're going to put it smack dab in the middle there. I'm going to put a little arrow there, and then I'm going to label that so we can see what that is. Okay, let's take a look at the other ones. Now, this is the same type of setup. You'll notice that I've got this expanded part of the number line between 0 and 1. And now we've got all these numbers to graph, and they happen to be in decimal form. So in in fraction form. In fraction form, let's be a little bit careful about this. If this is going to start off at 0 and this is going to end off at 1, and we're going to count in tenths, this would be 0 tenths, 1 tenth, 2 tenths, 3 tenths, and we'll just go all the way up the line, writing down each one of these. And you'll notice that right there we're actually graphing one of those. So there's 8 tenths, and then there's 9 tenths, and this would be 10 tenths. And again, you can tell that that would be the equivalent of 1. Now this one right here, 7 tenths, we can just put a dot right there and we're all set to go. So we've got 7 tenths right there. All right. 1/5, that's a little bit different. There are a couple things that we could do here. You may have noticed as I was writing this down that a couple of these could be reduced. Like that can be reduced to 1/5. That can be reduced. 2 goes in here twice, 2 goes in there 5 times, so that would be 2/5. Or we can take this and we can make the denominator a little bit bigger. So this is going to be, let's see, if we doubled that, that would be 10. So this is the same as 2 tenths. So this right here, and I'm going to put the dot there, and then I'm going to label it as 1/5. So we're clear on what that is. 1/4, you might recognize that that's the same as 0.25. So that's going to go in between 2 tenths and 3 tenths. So I'm going to put it right in the middle there, and I'm going to label that as 1/4. And then this last one, 2/3, well, you may remember that 1/3 is 0.3 repeated, and 2/3 would be double that, so that's going to be 0.6 repeated. So this is 0.66, just going on forever. So what that means is it's between 0.60 and 0.70. So it's going to be in between the two of these, 6 tenths and 7 tenths. and let's see, a little bit closer to 0.7 than 0.6, a little closer to 7/10 than 6/10. So I'm going to put that about right there. I'm going to label that as 2/3, and then I'm going to do one more thing to kind of make that a little bit more clear. If we're starting right here and ending right here, and we divided this into thirds, this is a little bit more difficult to do. 1/3 would be about right there, 2/3 would be about right there, and then you can kind of eyeball that if this is 1/3, that would be 2/3. So we got the right one right there. In graphing fractions can be a little bit difficult, so you got to be kind of careful when you're doing that. Okay, let's take a look at the bottom here. Most people like decimals more than they like working with fractions. Okay, it's just kind of the way things are. They like working with decimals more than they like working with fractions, until they learn a little bit. It does seem like that decimals are easier to work with, and they're definitely easier to put into a calculator. So decimals are really nice. They're easy to put into just about any calculator. But we'll see that fractions have some really nice properties that decimals do not have. And when we need to write an answer in exact form, we need to write exactly what it is, not a repeating decimal or anything like that, then fractions are definitely the way to go. Fractions are definitely the way to go when we want to write an exact answer. So the bottom line is we need to be good at working with both types of numbers, both fractions and decimals. They're both rational numbers. And we need to be good at working with both of them. And hopefully by the time we're done with this unit, you'll like fractions as much, if not more, than you like decimals. Okay, that's my goal. So now that we're familiar with how these rational numbers work, that we can write them in fraction or decimal form, we need to be good at switching back and forth. So one of the things that we're going to work on today is changing a fraction to a decimal. So if we take a look at the fraction 3/8, my question for you is, what operation is used to make a fraction? So we've got this little fraction bar. What operation does that represent? And that may be why people tend not to like working with fractions, because that little fraction bar represents division. And if you think about the order of operations, add, subtract, multiply, and divide, of those four, dividing tends to be people's least favorite to do. So that may explain why people don't like fractions. But if we're going to change the fraction 3/8 into a decimal without a calculator for right now, then here's the procedure we'd use. This is 3 divided by 8. We actually have to carry out that division. So the question here is, what goes on the outside? Well, another way to say 3 divided by 8 is, how many times does 8 go into 3? So 8 is on the outside, 3 is on the inside. And 8 doesn't go into 3, so what we do is we put a little decimal right here, add a 0, because 3.0 is the same as 3. I'm going to move that decimal straight up, and then I'm going to ask myself, okay, does 8 go into 30? And it does. It goes in 3 times. 3 times 8 would be 24. We go ahead and do the subtraction, and we end up with 6. 8 doesn't go into 6, so what I do is I add another 0, and 8 does go into 60. It happens to go in 7 times, so 7 times 8 is 56. And then there's 4 left over. 8 doesn't go into 4, and I just kind of get in the habit of kind of keeping things lined up, putting a 0 down here, and then 8 does go into 40. It goes in 5 times, so I'm going to follow this straight up. I'm going to put a 5 right there, do the multiplication. There's no remainder here, so that is the answer right there. So 3/8 written as a fraction is going to be 0.375 as a decimal. Okay, and that's the procedure we go through. We actually just go through and do long division. So let's take a look at this one right here. This would be 7/9, or in other words 9 into 7. So I'm going to put the 9 on the outside, the 7 on the inside. It doesn't go into 7, so I'm going to go ahead and put the decimal right there, line things up. 9 does go into 70. It goes in 7 times. Let's see, 9 times 7 is 63. Do the subtraction, we get a 7. It doesn't go into 7, so I'm going to add a 0 there. It goes in there 7 times, so that's going to be 63. And you can kind of see what's going to happen. This is going to happen over and over and over again. Every time we put a 7 up here, we're going to have a 63 down here. We're going to subtract, and we're going to get another 7. So what that means is this pattern just goes on forever. So 7/9 as a decimal is 0.7 repeated, and the way we show that that repeats on forever is we put that little bar over the top, and that bar is a grouping symbol that says, hey, repeat this group of numbers. This group of numbers happens to just be a 7. So this is going to be 7/9 would be 0.7777777. We can just put a dot 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 on the end. Okay, so we'd normally write it just like that. Now, I've got another question for you. What would we do differently if we were asked to change the fraction 4 7/9 into a decimal? Well, there are a couple things that we could do. We could change this to an improper fraction. So we could do 9 times 4 is 36. 36 plus 7 is 43. So we could do 43 over 9. And then we could do 9 into 43. Let's see, it would go in 4 times. That would be 36. There's 7 left over. Doesn't go into 7, so we'd have to start adding zeros, and then there's a 7 and so forth. You could keep doing it that way. You'd end up with 4.7 repeated. Or we could just do this. We could say, well, this is going to be 4 plus whatever 7/9 is. So that's going to be 4 and we already figured out what 7/9 is. 7/9 is 0.777 and so forth. So it would just be like this. Okay, which we could write as 4.7 with a bar over it. That's probably the quickest way to write it. Okay, so one thing that I definitely want you to note is when we change from a fraction to a decimal, the numbers after the decimal will terminate. In other words, terminate means stop, or they'll form a repeating pattern. Okay, so we've got two examples right here. One of them terminates. Like 3/8, when we change it into a decimal, it stops. Okay, just stops cold right there. 3.75, that's it. This one goes on forever, but it has a repeating pattern. So this one terminates, that one stops. This one has a repeating pattern. So if you ever see a decimal number that stops or has a repeating pattern to it, you know that that came from a fraction. It came from a rational number. Okay, now let's talk about how to change from a decimal to a fraction. In order to do this, we just need to be smart about the way we say this. So for example, how would we say this number? And when we say how would you say this number, you need to say it correctly. A lot of people just say 0.45, but we're talking tenths and hundredths here. So if we said that number correctly, it's actually 45 hundredths. 45 hundredths. Well, 45 hundredths is a fraction. If you weren't looking at this right here, if somebody just said to you, hey, how do you write down 45 hundredths? The way you'd write it down is 45 over 100. And there's our fraction. That quick, we're there. We do want to make sure that we write it in reduced form. So we want to look at this and see if there's anything that would go into both of those evenly. This ends with a 5 and that ends with a 0. So 5 goes in here 9 times. And 5 goes in here, let's see, 100 divided by 5 would be 20. Okay, so 29ths, that's in reduced form. So this is actually a very quick process, much quicker than changing from a fraction to a decimal, because all we have to do is say this decimal correctly. So this is 18 hundredths, 18 over 100. Notice that they're both even, so 2 goes in here 9 times, 2 goes in here 50 times. 9 and 50 don't have any common factors, so we're done right there. This is 69 hundredths, so that would be 69 over 100. 69 and 100 don't have anything in common, so we're done right there, no common factors. And this is only 9 tenths, so this would be 9 over 10. And again, they don't have any common factors, so we're done right there. So much easier to change from a decimal to a fraction than it is to change from a fraction to a decimal. But that's the basic process, and you need to be good at going back and forth, again, without a calculator. So good luck on your homework.